CH4 gas. Plus copper oxide. Isn't it? Alright, so same thing again from here. First thing we do, we list the oxidation number for all the iron atoms in the compound. Alright? So carbon, hydrogen. Hydrogen here is +1, therefore carbon mostly.
Carbon.
4 minus 4.
Copper is
+2.
Oxygen is
-2.
copper here is
0.
why?
That's in pure state.
Good. That's carbon, hydrogen. Oh, carbon and oxygen. Sorry, what's oxygen here?
-4.
Oxygen. What's the rule of oxygen?
-2.
Thank you. Therefore, carbon must be
+2.
yes.
-4.
+2.
+4.
+4.
Hydrogen, oxygen. Oxygen is what? And that's oxygen +1. Alright. So
So the total charge on the carbon oxide is supposed to be
as long as the compound total charge is 0. Not calculating anything aggressive. Alright. So which reactant oxidize which is reduced, which is oxidized which is reducing agent. So reactant that is oxidized. Which one? Two reactant I have enough. Which is oxidized?
we should oxidize.
Lower.
CH4. Which one is oxidized?
Which is reduced.
Oh, English oxidized.
And why?
Copper.
What do you mean by something is oxidized?
Oxidized. Glass.
CH is oxidized.
No, it's oxidation number we're talking. That's why I didn't want to give the two definition.
It increase.
Oxidized means loss of electron.
Or what? What in terms of oxidation number, what is oxidized?
Is oxidized.
It increase.
Oh, look at the definition.
0.
The first page. This should be the first page of the notes.
Loss of electron.
Oh, a carbon there, sir.
Good.
Carbon, because carbon move from -4 to +4.
Good, good.
Oh.
Yeah, so I'm gonna say it in knowledge here.
Sorry. They didn't give me the reason. It's answer plus reason, you know, alright? Yeah, give me the reason?
Yes, sir.
Oh, sorry. -4 to +4. Oxidation number of carbon increase from -4 to +4. That's increase, right? Which one is reduced? Must be the copper oxide, eh? Because what?
It
Oxidation number of what? Copper decrease from +2 to 0. Which is the oxidizing now, which is the reducing agent.
The oxidizing agent is a copper.
Using agent is the
Carbon hydrate.
it's really methane. It is organic chemistry, right? Methane.
Methane.
Good.
One
Ah,
carbon,
okay.
one carbon,
One carbon,
and
good.
4 hydrogen.
Good. We cover organic chemistry already, so call it the right name, alright? So that would take care of understanding the rules to calculate oxidation number and identifying compounds that reduce and oxidize, alright? Alright, let me just tie the two definitions together that in terms of electrons and oxidation number, alright?
Sir, do you have an excuse?
Sure. No. Alright, say for example in this case we had sulfur. So sulfur moved from 2 minus to sulfur solid, which is 0. Right? So from -2 to 0. Alright? This is oxidized. So it's oxidized. And far from the previous example, you know. Remember? This was oxidized. That was oxidation number of sulfur increased from -2 to 0. Alright? No. That's oxidized. In order for the oxidation -2 to become 0, what would we have to do here in terms of sulfur?
So that's a gear.
Outer shell, so this is sulfur is what? What's the atomic number for sulfur? Below oxygen in the periodic table. And I'm certain it has 16. It has 6 electrons in the outer shell. It will have 8 in the second shell. That's 14 plus 2 in the first shell, 16. Here? So it simply means that in terms of the outer shell, it will have 6 electrons, right? So this is valence shell only, represented for the sulfur. Following? No. So this is the case in which would represent here, valence shell here. I'm just write it down here for understanding purpose. I'm just trying to show you here why, if you know the definition in terms of increase, decrease in oxidation number in the exam, you can actually reason out the electron loss or gain, alright? Sulfur, 0. Alright, so this is the solid anion. Alright, that's atom ion. Alright, so ion, atom. Alright. So this was the atom that has 6 electrons in the outer shell. So it simply means that if it became stable, you would have got 2 extra electrons, right? You'd have to get electron here, electron here. No. So it simply means that if this was oxidized and we have increase in oxidation number, we can remember the number line -3, -2, -1, 0, and have +1, +2, +3. So this number line. So that way would increase. If we move from -2 to 0, we're actually increasing oxidation number, right? And to move from -2 to 0, we'd actually be losing 2 electrons to make that conversion, okay? Therefore, oxidation because it can actually reason out oxidation number in terms of electrons. Alright? So if you study and have the knowledge in terms of oxidation number, because it's easy, you know, oxidize, increase, reduce, decrease. If you know that, you will just reason out everything if they ask a question in terms of electrons. Alright? Alright, let's just talk about some common oxidizing agent and color change, and then we can finish for the day. And you should go home and review with us, alright? But we need to know about like common oxidizing and reducing agent that you will get in experiments or that occur in real life, right? So common potassium permanganate, so this is potassium. Potassium dichromate, O7. Iron 3, aqueous iron 3. Alright, let's just use these 3. Alright? So normally the oxidation state for manganese here is +7, for chromate is +6, this is Fe3+, alright? So normally KMnO4, so it's the manganate ion. When this is acting as an oxidizing agent, it will be reduced to Mn2+, alright? This is purple, this is color. Yes. Alright, as you can see, manganese here is +7 and it is reduced, so it is acting as an oxidizing agent. Alright, our potassium dichromate is orange, there's a color chain. This is green. Alright. Miss Sparks, from qualitative analysis, if Fe3, what's the color of Fe3?
Yellow brown.
Good. From yellow brown to? Good. Those are 3 common oxidizing agents, right? Then common reducing agents are potassium iodide and iron 2, right? Moving on. Alright, so those are stuff that you don't need to know. Let me see what else they could possibly give you. So it simply means that, And then some substance discussed here can behave both as an oxidizing and reducing agent. So you can probably read up on hydrogen peroxide for your homework, alright? Alright, so common oxidizing agent, potassium permanganate, potassium dichromate, iron 3, alright? And we're going to look at common reducing agent. Alright? Alright? No. So, when this is acting as a reducing agent, we have I minus converted to I2 is liquid, right? This is colorless, and iodine is what? Right, and then again here Fe2 plus go to Fe3 plus. So this is pale. So common reducing agents. These are two. We can go and read on others, alright? And then compounds that can act both as oxidizing and reducing agent. Oxidizing and reducing agent. Here I have compounds. Hydrogen peroxide, right? Right? Just hydrogen peroxide, right? So as you can see, if we react hydrogen peroxide as strong oxidizing agent such as potassium permanganate, it will act as a reducing agent. If we react hydrogen peroxide with a strong reducing agent such as potassium iodide, it will act as an oxidizing agent. So you can read up on reactions of this for a moment, right? B